recovery, there cannot be reclamation or reuse. A-Gas Rapid Recovery is an on-site refrigerant recovery service that gives businesses an easy way to contain their used refrigerants.
Not a whole lot of companies do what we do. We handle some of the grunt work that they don't want to do, and we can do it 10 times as fast as they can. The recovery portion, cylinder exchanges, and buying back used material that otherwise can't be used.
We play a big role with our contractors, whether that be HVAC, mechanical, or demolition contractors. Our whole purpose is to get on site and not only help them save money in the project, but offer an environmental solution.
We do not want any of these products getting vented to the atmosphere, no matter how low the GWP is. Now it's not only the cylinder to recover the product, but it's making sure the technicians have equipment that are rated to work with flammable gases. That's really important for people.
So by us being able to contain it in cylinders, reclaim it, we're saving the environment one recovery at a time.
My name is Mike Idle. Today I wanted to give you an overview of Amatrol's T7300 HVAC control system. This system is designed to align a hands-on workstation, as you see here, along with interactive curriculum to teach the operation, installation, application, and troubleshooting of control systems related to the HVAC industry. As components and features of HVAC systems get smarter in both the residential and commercial fields, it's important for current and future HVAC technicians to be trained up. What types of circuits are used, familiarity, learning, operation, maintenance, troubleshooting are all important areas to cover in that.
Here at NAVAC, we are obsessed with delivering the best HVAC tools on the market. Our tools are built for professionals and engineered for precision, just like Harley-Davidson motorcycles. NAVAC Nation, it's time for you to feel the power both on and off the job site. Let's stand up in our pursuit of perfection. From coast to coast, NAVAC forges the path forward. Wherever you are, we will be right beside you.
Well, hello everybody. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. We spend lots of time talking about technology, innovation, the things that are changing within our industry. And when we can merge data and technology, we create an innovation that changes the way we do our job. And it's the goal of using technology to help us be more efficient at the things that we do. As we are evolving into new generations of equipment, new generations of refrigerants, a shortage of adequate labor within the industry, we have to look at the different ways to be more useful with our time, to start embedding technology into the environment that we work in. And I've done a lot of posts and got some very mixed feedback on how soon artificial intelligence and robotics and automations are going to merge and become physical within our industry. And I think we're really at that point, and we're going to discuss that today. So we've got two fantastic guests with us today. We have Justin Morisak, president of CSG Compressors. How are you doing?
Great. How about yourself?
I'm doing well. I'm very excited about this conversation. And we got Kyle Massey. Kyle is the co-inventor of SAMMi, which is going to be the technology that we're going to be diving into today and utilizing data that's been collected over time. And let us know where you're joining from. We're grateful everyone is hanging out with us today. Here in the Midwest, looks like we're getting ready to prep for a winter storm. I think we're looking for about 12 inches of snow over the weekend, so I'm getting kind of excited about it. And we've got AHR coming up in just a week or so, so we'll be coming by and hanging out with these guys, learning more about what's going on in our industry. I encourage all of you to come by and see us. Now, when we talk about the introduction of artificial intelligence. When I put this post out, I talked about the AI technician that is joining our team. Now, we have to be cautious when we look at artificial intelligence and understand the benefit of it. There are a lot of industries that worry about artificial intelligence replacing their jobs. And for us, the essential skilled workers, it complements what we do when we do it properly. So when we think about like CSG compressors, like, hey, thanks, Jared. Glad that you're joining us. And by the way, I'm here in Brownsburg, Phoenix. That's got to be some decent weather right now. Yeah, you need to let us know how things are in Phoenix. And Andrew, appreciate you joining in from San Francisco, but we get the good weather out there today too. So I'm in Brownsburg, just outside of Indianapolis. Why don't you guys go ahead? Where are you joining in from today?
I'm here in warm at the moment, Houston, Texas.
Oh, that sounds good too.
Not for long. Not for long. It won't be warm for long. We're going to get it too.
Soon to be frigid Oklahoma City.
Oh yeah, I enjoy Oklahoma City. I was out there. It's been probably 5 or 6 months ago. Went out to a DSR meeting for Bosch, and TSA meeting for Bosch, and then I've also been out there and done some factory videos at the Norman, Oklahoma facility. So I get out to that area quite a bit. Yeah, 72 and sunny. Oh man, hey, Osvaldo, hey, it's been a little while. Glad that you're joining us from Belize. Man, Osvaldo's the one that's got the weather now, and we really appreciate him joining us. Osvaldo is a technician in Belize and joins our show very regularly to learn about what's happening in the industry. A lot of places around the world are looking at the United States because of the technology and the innovations that we are adopting and introducing into the industry. So when we look at compressors, I spent a majority of my career as a commercial refrigeration technician, a lot of grocery rack refrigeration, a lot of stationary. Kendrick joining us from Chicago. Thank you. Yeah, you got the tropical down there. I know. You don't have to tell me. I think we're going to have to do a live show from Belize sometime. Yeah, that's true. I bet, yeah, understand. All right, so as a technician, I spent a couple decades in the field. And over time, by working with a variety of different pieces of equipment and then re-seeing some of those pieces of equipment, after becoming an experienced technician, there were some key things that I could listen to, things that I could notice. And before I dove too much into a piece of equipment, go, okay, I got an idea what's going on here. Now let's use some diagnostic tools and let's gather some data. Well, how long has CSG Compressors been in the industry? And let's talk about some of the data that you've been collecting along the way.
Sure. So our founding company was Houston Hermetics, and Houston Hermetics was started in 1966. So this is actually our 60th year in business.
Wow.
And at that time, we were doing real small reciprocating pots back in the 60s. And in 2019, we created CSG Compressors, to where we started combining multiple entities onto one to broaden our footprint and also to broaden our product offering and our services offering. But you can imagine, through that many decades of literally listening, feeling, smelling, the compressors when they come back in, because we're a remanufacturer, right? So we get everyone's trash, which we find is treasure, right?
Crack that valve plate off.
Yeah.
Oh, yeah. You got a little roasty on this one.
Yep, that one's been burned. So, so no, over the years, of course, similarly to being in the field as a technician, you walk up on a rack and something just doesn't sound right. Well, we can do the same, and so we've been compiling that data for decades and decades and decades, and everything we know is centered around the compressor. So when we go out to the field to help technicians, we're listening for specific things around the compressor. But over time, we start to learn like what's causing those sounds or vibrations or reactions in the compressor itself.
Yeah, for sure. So the whole mechanical side of it, right? Understanding how a system operates, like when something fails, how does it react? Like, what do we see in that? Well, so we take the physical side of things, the mechanical side, and then we introduce the technology and software side of things. So Kyle, tell us a little bit about SAMMi and what that style of technology is doing.
Yeah, absolutely. So, SAMMi was an idea that came from in the HVAC industry in particular. We will always need people on the ground. We will always need
right.
hands to go and fix the actual devices. So the problem that as we were developing SAMMi in other industries, because SAMMi isn't just an HVAC technology, Justin and I partnered up, and he said that we have all of this data on these compressors, and HVAC technicians get a call and they have to go out and they don't know what they're going to find until they get there.
Right.
And it would be really great if we could help our technicians get a head start on what they're going to encounter and maybe even know what the problem is long before they get there.
Yeah.
And so SAMMi has really been designed around helping the technician have as much information from the physical system before they ever get there, so they know what they're getting into. And then as we started to build that and pile on the amounts of data and information and history that a compressor remanufacturer has and how these systems should run, and talking to technicians, we can begin to compile these years and years of experience that is so hard to find now.
Oh, yeah.
Coming on a podcast like yours to find this much experience in one place, the same way that you're trying to share knowledge, we are trying to digitize some of that knowledge and help folks be able to grab at that information and give them some of those precursors to failure.
Exactly. And Jared, you are exactly right. And that's why we pride ourselves on this show of bringing the top industry educators, the most experience within the industry. Because when you can use things like AI with, validated data, when you put in good information, you're going to get good information out. It's when we have that incorrect data that's being fed into it, that's when we can really start having some concerns. Oh, you're right. It's another thing that we see, right? Incorrect data coming in for that. Like we could even send the wrong technician to a job if we don't know exactly what's going on. Joshua, hey, grateful. Another one joining us from Texas. Glad to have you here with us. Well, let's dive into, we're going to bring the presentation in and let's talk a little bit about this evolution. And let's talk about how we are actually introducing AI technicians into the field, not as a physical representation, but definitely as a technician as part of your team, because it brings a whole new level of professional development and professional skills to a contractor. And for those of you that are contractors out there, especially if you're in the commercial industry, this is going to be your cup of tea. And our educators that are looking at tools and techniques and technologies to introduce into your classroom, this is it. Because I've been to many of the classrooms. A lot of the educators that are going to be with us today and watching in the future. And we have a lot of refrigeration training happening in the classroom. Well, what if you can now start introducing the service side of it, the technical skills and the technology into those curriculums? That'll change the game for the technicians that we're introducing out into the industry.
Absolutely.
For sure.
Cool. Well, let's dive on into this. Let's start learning a little bit.
Sure. So ideally, SAMMi is a tool, right?
Yeah.
As Kyle pointed out, in our industry, it's always going to take hands to get the actual work done. And the shortage of labor that we're going to see in this country over the next few decades is going to become an issue. And time is going to become of the essence, right?
I agree.
And so we've all been on those job sites to where the customer wants us to effectively babysit a system 24 hours a day to figure out why this thing isn't running right or why this thing is failing.
Exactly.
The problem is the person that probably historically could tell you that by sitting there for hours is generally the most senior person within your organization or your most highly compensated person in your organization, or maybe the owner of the company. So, and that's just not a reasonable solution to finding problems. So when we were developing SAMMi, it's, how do we get all of that knowledge from all those problem solvers within your organization, or the technician that maybe has taken vacation or maybe retired, but how do we get all that knowledge and keep it and then apply it to the system? Well, SAMMi can be those people. It can be that lead technician that your customer wants to be sitting on the job site for 24 hours a day, 7 days a week, monitoring this system. And then actually point to where a problem is going to start taking place, and then dispatch the right person, the right technician, the right problem solver to that job, all while having no downtime, no overtime, and no guesswork. So SAMMi's a tool to help, and SAMMi comes equipped with the same set of tools, same set of gauges, looking for the same information that any technician is going to do as soon as they get to a problem job site.
We recognized within the educational industry just shortly after COVID, the impact that COVID had to our industry for the tribal knowledge.
Right.
We had educators that had been in the industry for 20, 30, 40 years. When COVID came around, many of them took early retirement. So we started backfilling with younger educators. And what we found was we were bringing in these very hungry new educators that were very excited to work in the classroom. But some of the things that they lacked was that tribal knowledge, that in-field of experience that is critical when we're talking about refrigeration equipment in particular, and when we get into our residential and like commercial air conditioning. So for an industry, we started backfilling a lot of our educational roles with lead technicians.
Right.
And so now we even have a shortage of those lead technicians in the field. But right now we are witnessing, and it's a beautiful thing, we are witnessing record enrollment for HVAC programs across the country. We have classrooms now that have 10-fold request for classroom participants than they had 3 years ago. Literally, we have classes that had 25 applicants in a year, and this year have got 250.
That's amazing.
So we have the bodies coming into the industry finally. Where we're going to suffer is this. How many new technicians and new students are we going to have per instructor and per lead technician? And it's going to be very different than the environment that I grew up in.
Correct. And us being in the industry as long as we have, we've also seen this train coming down the tracks.
Oh, yeah.
And, ours is measured with different metrics. We measure our warranty rate. And that is a direct reflection of what we're doing in-house, yes, but also how these are being installed and how they're being cared for once they're in the field, meaning the compressors, right? And so over time, you start to see very similar failure rates or areas of failure. The rate is going up. And unfortunately, it's due to either neglect because there's just not enough technicians to go do those PMs, change oil in compressors or something like that. And we start to see an uptick in warranty claims, and they're not necessarily the manufacturer, but it's just lack of manpower. Yeah. And if a service manager could know that a compressor was heading towards failure, you could then reallocate the resources that you do have to go attack that issue before it becomes a catastrophic problem. What we can do with SAMMi is take that information from not only the manufacturer standpoint, but also the service managers, as you call it, tribal knowledge, and build it into SAMMi so that this new technician coming into the field, it takes time to learn. And we understand it takes touch time on the equipment. And we understand that. But we can load that tribal knowledge into SAMMi so that their job now becomes more narrowed, and that now I know that there is a problem there and I know what kind of problem it is. So that's not this large, overwhelming issue that I've walked up on a failed piece of equipment. It's we've got a compressor that's short cycling and now I know which direction to go to. So yes, we saw the same issues coming down the tracks several years ago as well. Mm-hmm. So it's great to hear that these schools are seeing an uptick in registrations because the labor is key.
It is. It is a very impressive thing to watch. Our own conference is growing by leaps and bounds. We're having record attendance year after year for the last 5 years. You know, Jared, you're exactly right. It's not just the young technicians coming in. You know, we are seeing industries being affected. There are a lot of software companies and engineers and developers that are starting to struggle. There are curriculum developers that are starting to struggle because AI is replacing a lot of those keyboard jobs that we've traditionally, focused on, 4-year degree programs in the past, and now we have an entire generation that wasn't even told about the trades. They're going, wait a minute. What do you mean that you have these like high paying jobs that have a lot of job satisfaction, and you have cool new AI tools that can predict problems so I can actually go to the job with the right things, and I don't feel like I'm starting from ground zero. I feel like I've got my own tutor that's watching these systems for me and giving me prompts, giving me commands of things that's going on. And yeah, Paul, you're 100% right. We are really talking about predictive maintenance when we start looking at SAMMi. Yeah, you're right. It's not just our industry. And when we look at labor, boy, it is a secure place. And when we have this knowledge in hand, we can bring in people from other industries and we can provide them with the tools that will help them be successful. The environment that I came from, I'm still very good friends with the regional director. Every conversation we have is like, I can't find technicians, or they're going from HVAC to refrigeration and they've never seen this stuff and they don't want to touch it. They're afraid to work on it. They don't know where to begin. How can we do that? Well, here.
And that's one of the things that we really wanted to focus on with SAMMi and HVAC is there are a lot of control systems and there are a lot of things that monitor control systems, but that is, we wanted SAMMi to take direct measurements off of the systems in a way that a technician would, because we saw the value. You can't get that tribal knowledge, as one of your commenters said earlier, from the machine itself. It can't tell you how to troubleshoot itself. Right. But by getting the same set of gauges on every piece of equipment out there that you would have, we can start to train not just SAMMi, but technicians on this is what this type of failure will look like. This is how these things move in the real world. And so SAMMi is being taught by the technician, and the technician is being taught by SAMMi at the same time, because we are cataloging these failures that otherwise you're just completely lost to the wind. No one ever can recreate those things. It's already over by the time someone has gotten there. In this case, you can download that data and you can see it as pressure and temperature and amperages the same way that you've been trained, and say, okay, that makes sense to me, or that doesn't make sense. And we start to complete that knowledge loop. And that is really helpful for the industry and for the technology.
I'm glad you brought that up, because that's an important part that I have even failed to bring up, that we're not just talking about SAMMi as being a software. We're talking about a hardware integration as well, which is
Correct.
how they complement each other.
Correct.
Actually, I've got a little video. I'm going to jump over to that video. It's only a couple minutes, just kind of a teaser for everyone. Make sure they hang in to learn the rest as we go along. Let me go throw that on, and I'll see you all in a couple minutes.
SAMMi isn't just another tool. It was developed to make responders more effective, more impactful, and always a step ahead, ready to act before problems even arise. Imagine this. Your technicians already have everything they need to solve a problem before anyone even knows there's an issue, including you. No scrambling, no surprises, just smooth, seamless operations. Our AI-powered platform autonomously collects your equipment's inbound data, analyzes it using algorithms tailored specifically to your operation, and turns it into easy-to-follow actions for your field team. We bridge the gap between machines and technicians. Traditional dispatching works something like this. First, the equipment fails. The customer notices and calls you. You identify the right tech who shows up, diagnoses the issue, realizes they need parts, and heads back to get them. Hours and profits wasted along the way. Now, here's how SAMMi changes the game. Before the equipment even fails, our system catches the problem early. The equipment sends out a signal.
SAMMi diagnoses it, assigns the perfect tech, recommends the right parts, and gets things fixed before the customer even knows there's a problem. Monitoring equipment isn't new, but here's what makes us different. Smart dispatch. We pinpoint the issue at its source, send the right technician the first time, and eliminate wasted trips, delays, and downtime. SAMMi, identifying problems before they exist.
It's pretty crazy. You're right. It's like having your own senior technician on site. So Jared, great point. We'll be diving into that. Just hang on here a little bit and we'll show you how the technician is actually reading the data. So you're basically, you can imagine, leaving a set of digital manifold gauges on every piece of equipment that you want, and it's feeding you data regularly. It's pretty exciting stuff.
Yeah, and as you pointed out before, there's a marriage of hardware and software that goes along with this. And working with technicians for my whole career from the manufacturer side, I really had a good understanding and respect for what tools they're carrying and what things really are important to look for whenever they're going to diagnose, these issues. And as Kyle pointed out earlier, usually what's happening, especially with the compressor failure, everything is post-mortem. So you don't know until you get that next machine fired up. And that's the scariest part for a compressor remanufacturer is that, all right, we just had one that failed. Let's stick in another one and push the big red button and see what happens.
Right.
And then the diagnosing can start, right? Unless it's something obvious, you have a pool of oil underneath it or a burn or something like that. But having that hardware piece and designing it in a way that's simple to use, as you said, it's essentially a set of manifold gauges that we're going to leave on site. That every 5 minutes it's uploading data and analyzing and using our algorithms and AI to help track the performance of that system. That's all centered around the compressor's performance and start doing SAMMi's job, which is helping everyone understand what's going on and catching failures before they actually happen.
Super, super important thing. We were going to do a couple weeks ago, I was going to do a show with FM Hero over the refrigerant regulation changes. We're going to do that the week after AHR. A lot of contractors aren't even aware that, the EPA is moving our required refrigerant monitoring from 50 pounds down to 15 pounds for, leak rate inspections and recovery time. So a system like this, you're even getting an idea if you've got a refrigerant loss, when you're seeing capacity changes and superheat changes. And
Correct.
Wow.
Yeah. And before an end customer, the homeowner or the ice cream store owner notices that his suction line is all iced up, we're going to know. We're going to know way in advance that we're tracking those PT charts live. And when we start to see a change, there's going to be a red flag there that sends out an alert that a system is headed towards failure. That in that particular instance, it would be refrigerant loss. So the technician would know, again, exactly where to point to. We can't tell them where it's escaping from.
Exactly.
However, we can tell them what refrigerant is in that system because, as one of your followers pointed out a little while ago, it's good information in, good information out. As long as the system is logged correctly on commissioning of the SAMMi, all of that information is going to be available to the technician. There's not a question of, well, what refrigerant is in that system or what application it's being used for. All of that is captured beforehand, including the nameplates, serial numbers. All of that information is collected up front so that, again, the technician can go out fully educated on what the system is and what's going on.
Love it. Another great question that came in from a LinkedIn user, is there CE credits for the course? Absolutely. This is an educational curriculum. After this show is done, we'll actually finish this into a polished video. We will add an assessment to it that is questions that are covered during this conversation. And if you're looking for a CEU for $2.99, you can actually get your CEU certification once you pass that assessment. So you can simply go over to escogroup.org, go to the Did You Know page, and it will be right there for you. Sorry to interrupt you. I just want to make sure everyone was aware of that.
That's great.
All right, let's dive a little deeper.
Sure. So when partnering up with Kyle and kind of fine tuning this technology to our industry, we really just sat down and had a good old fashioned pencil and paper session of what are we trying to figure out? What problems are we trying to solve? What issues can happen to cause a compressor to crater? And so we just basically started a yes/no conversation of, is this important or is this not? And so Kyle is really kind of the Wizard of Oz of this thing, that he makes all the magic happen in the background. So he's absolutely a maniacal genius when it comes to this stuff. So I'll let the resident expert, maniacal genius, wizard behind the curtain take over.
Sure.
And tell you exactly how we're doing what we're doing.
I think maniacal genius, that's the first time I've ever been described as that.
So I like that. That sounds
I might get some business cards put together for AHR with maniacal genius on them.
I would.
Just use it as like an accreditation, like MG.
That's right.
There we go.
Yeah, there you go.
Like we said before, the amazing thing about HVAC, and the thing that we were so excited about it, is it's one of the industries that you can have direct measurement of the system. And so that made what we were trying to diagnose and what we were doing so much fuller in what we could take in from the resident experts. If it's an electronic control module, you're only getting error codes, and that can mask itself as a lot of different things. And so what we decided early on is it needed to be gauges. And if it's gauges, then, in asking technicians, what matters to you? Which gauges do we need to have? Where do we want to put these things? And then PT curves, let's load those in, because you care about all the things that come from your PT curves. And then it became pretty clear that although SAMMi is intelligent and we can preload as many scenarios as we want, as I started to go out into real life installations, again, like a new technician learning, it was, wow, this is not at all like what the book or the picture on the internet said. And what do you mean defrost cycles? And what do you mean all of these other things? And so those waters got very deep very quickly. So it became really evident that our alarming system couldn't just be, as you just said earlier, AI is not at a state where it can go out and pull all the failure mechanisms. Exactly. Because it doesn't know what each system is. And it doesn't know how it's supposed to run. So as AI is learning and training, we are also allowing the users to input their own system parameters. So anytime a technician sets up a new unit, if there are specific alarms to that unit, may it be pressure settings, temperature settings, combinations of those things, that this system should always run above a certain suction pressure and temperature combination, they can very easily go in and input as many different unique alarms to that system as they want, or they can put very basic ones if they want. And so every system has the opportunity for a technician to be as creative as they want in the things that they care about on that system. And where that is just absolute gold for us in the industry is now we are able to learn what really good technicians start to care about in the complex. So someone who is setting up a hyper complicated refrigeration system, we see those alarms and you think, oh my goodness, I would have never thought to chain these things together or care about all of these things at the same time. And now we have just this wealth of knowledge of, kind of outside the box thinking.
So the tribal knowledge, the tribe gets bigger.
Yeah.
So what we can see is, if there's a common subset of alarms that is used across a large population of technicians, now we can preload that in and say, look, this is really what, in a refrigeration system for your ice cream shop, this is really what your alarm should be set as. Yes, you can still tweak them, but we can preload those things in to make that tribal knowledge to be able to be spread across different companies and different technicians in different parts of the country or across the world, to share that knowledge.
Very intriguing question that just came in from Jared. And Jared, I thought the very same thing when I had this initial conversation. I was so impressed with what they're doing for the refrigeration. It's like, wait a minute, where's our residential HVAC here? What else can we do? Technology is a beautiful thing because you can always ask, what else can we do down the road? And so if you think about even an inverter, right, we are measuring temperatures, pressures, and we are measuring compressor amp draw. So there's a lot of data points that we could be monitoring and tracking over time. So the possibility is just infinite.
Correct. Yeah. And Kyle and his team did an amazing job of making this thing scalable from your typical 1.5, 2-ton residential split system all the way up to the most complex centrifugals or thousands of tonnage of screws. And it doesn't care what system it's hooked up to. It just cares that all 7 points of data are being recorded, and it wants to know what rules you want to play by. And that's really it.
Yeah. No, Paul, and we are talking about an add-on component. We'll show you here in just a minute what the actual device looks like. I mean, just think about a permanent set of digital manifold gauges that's also got a amp clamp tied into it as well. So you're leaving your entire digital tools on site for the piece of equipment.
That's correct. And so, as Kyle pointed out before, there's tons of technology out there that already exists for building automation or monitoring of equipment. And we're fully aware of that. And all those things are fantastic at what they do. And many of them in use today all across different platforms. And what we felt was missing from that was, rather than having that as a pull information from the user, we need to push this and to get it out to the technicians, but then not to stop there. It's to autonomously dispatch or at a minimum have the ability to autonomously dispatch the right technician for the right job. So, and Kyle, of course, you can jump in and tell them how we're doing this, but that really for us is what sets us apart from what's available in the market today. It's matching that smart monitoring with the smart autonomous dispatch feature.
Yeah, absolutely.
And yeah, that was a big learning for me, is that these systems are so different, and who works on different systems, and the whole refrigeration versus air conditioning side of it. Those were all new for us. And the same mechanical contractor may be working on things that the entire technician pool doesn't typically work on. And what we wanted to do is we can preload who should be responding to which of those types of alarms and those types of systems and those customers, so that we don't waste time with the wrong technician shows up and realizes it's something that they can't work on, or the customer's calling dispatch and asking what's going on. In this case, SAMMi looks at it. It identifies through the rules that have been set up in it by the users. And then, just like your favorite rideshare app, it picks your best responder based off of proximity and allowable rule set matches, and it will dispatch that person through an iPhone or Android app. So your technician, when they finish their job and they close out the job that they were on, is available to get a new job immediately. Whatever the next most pressing thing that they are the best suitable to go respond to, it gives them, this is the failure, this is where it is, this is what SAMMi thinks it could be. And so they know exactly what they need. And if they can, as we get better and better and SAMMi learns more and the organizations that are using SAMMi get more familiar with it, you can decide right then and there, I don't have the parts to fix what I think I'm going to go fix. This is obviously something I need to go back to the shop for. And if we can fix one thing, it is excess drive time.
Oh man,
back and forth, because that is just dead time for everyone, and no one likes drive time to and fro.
Yeah, 20% of every technician.
The efficiency we can add back to the technician in the industry by just shortening that cycle is really where we think SAMMi can immediately add productivity uplift.
Well, think about all of the contractors, especially in the residential, light commercial HVAC sector, that are now doing service contracts, utilizing thermostats and a few room temperature sensors to kind of monitor the performance and actually have it as a service, a monitoring service of the home system. This has taken it to an entirely different level. I mean, this is live monitoring of the performance of a system.
Correct. And, to add on to what Kyle was saying about, sending the right person out with the right credentials, like your favorite rideshare app, it doesn't matter if it's 2 o'clock in the afternoon or 2 o'clock in the morning. SAMMi's going to make that same decision. So if you do have these hypercritical jobs or contracts, usually that dispatch person isn't awake taking the call at 2 a.m. There's some emergency call going out. It's usually to the most highly compensated person that's on the payroll, and there's overtime involved, and that may not be the right person to send out. But if the service manager or the dispatch manager has already placed those rules in and says, if this job has this problem, we're sending out this person, 2 a.m., 2 p.m., doesn't matter. SAMMi does it the same way every single time.
And can justify it based on
Correct.
data.
Correct.
Now,
Absolutely.
what about the communication? What type of protocol are we using for communicating? Is it tied into a landline or?
So SAMMi is set up. It will do either Wi-Fi or cell. But one of the decisions we made early on is that SAMMi needed to be able to operate under its own power supply. So pull power from something other than the system and be able to communicate via cell, because that was one of the other pieces of information that was really critical that we kind of stumbled on. Is SAMMi will continue to communicate your system status even if your system loses power. And that was one of the things that we realized was also extraordinarily beneficial, is you're responding to what we think is an environmental issue, and in reality you have a power failure or you have some other type of disruption to power. So SAMMi will always communicate. It can go to Wi-Fi if you have unique situations where cell phone service is kind of suspect. We can do Wi-Fi, or if you have a certain situation where you just want to use Wi-Fi, but every SAMMi comes with cell built into it. That's just part of how the SAMMi hardware suite is configured. And so when the technician receives it, all of that is already built into it. You don't have to do anything other than just take a picture of it and get it up and running.
And secondarily, the reason that cell service is the first and primary choice for us is that we know that most of these systems are in places where the Wi-Fi is going to be controlled by the business owner, right? Or the actual customer. And I would imagine that the technician that's servicing their HVAC equipment is not high up on their list to let them know that their Wi-Fi password has changed. So for us to receive a down signal that our SAMMi is offline, and for it to go through the whole process of sending a technician out to figure out that, well, it didn't lose power, it didn't lose communication, it lost access to the Wi-Fi. So we try to avert that as much as possible, and using cellular just makes complete sense. In the way that the product is packaged, there is no additional cost for adding on a cell service plan to your current plan, or buying a SIM card to your current or existing plan. All of that is included with SAMMi. All the data that it transmits is already included with the cost of the monitoring of the equipment. And so we've really just packaged everything to want to make it as simple as possible.
Wow, I love that. Andrew, I know it's kind of hard to wrap around, but so be thinking about, if I'm monitoring refrigerant pressure and I'm monitoring temperatures and I'm monitoring amp draw, I'm actually, like we previously talked, we're now following our enthalpy curve. We're monitoring the performance of that compressor. And so as our system capacity changes, we're able to compare that to previous data and actually have a really, really educated analogy of where that compressor is operating in its envelope. Oh yeah, that's a great video. Let me get this off of here. Let's go talk about that.
Sure.
So this is, you can't judge the installation skills here. Bear in mind, I am not an HVAC technician. So all wire bundles and everything aside, this is even me, who is an unsophisticated, untrained hobbyist. It takes me about 15 minutes to hook up a full SAMMi. So we are using, as Justin said, the same pressure sensors, temperature sensors that you would see on any other standard piece of equipment. If you're threading onto test ports just the same as you would with your gauges, you're able to just strap on the temperature sensors. And then we have clamp-on amp clamps so that we're not having to tie through anything else. We're not having to feed through or strip anything. So everything is made to be able to connect to the system. I guess technically if it were powered up, but I don't think that's the advisable state to do it. But you could technically go out there, and if you have an external power supply, you can hook SAMMi up on the fly. And once it is set up, as we said before, we have 7 sensors between amperages, pressures, and temperatures, and then you start to get all of that information. It starts coming in live as soon as the box is powered up.
Yep.
And so this is the full installation. It's sped up, but it's not tremendously sped up in this entire video. There are amp clamps, and then we have SAMMi's with both an internal antenna and we make an external antenna extender. So if you have spots where self-service is kind of an issue, or if it's under a metal shed, you can get an external antenna that just drags out, and you can place the antenna wherever you want so that the SAMMi can continue to communicate. So you're not having to run all of the wires any type of distance. They can all be mounted inside of the cabinet or near to the cabinet. We mentioned earlier, it'll up to 480 volts. So if you need to, you can pull off of power of the system. You can plug into an external power supply, any of those things. And then to add a sensor or to add a SAMMi, it is literally as easy as taking a picture of the QR on the SAMMi through our app, filling out some basic information. It's critical information, but it's pretty basic information. And once you insert this little bit of information, tell it what's going on, what type of compressor, the horsepowers, that's more so you know what's going on. And then we have our users take pictures. This is one of the things we figured out really quickly is one person installs a SAMMi somewhere different than someone else does. And so you go out there and look for it. So we decided that every SAMMi would have a picture associated with its file. So when you get an alarm, you know where the SAMMi is on the machine. Yes.
Yeah. Well, Carl
after
brought
5
up.
minutes. Oh, sorry.
No. I'll come back to it.
I was saying after 5 minutes, you start getting real-time updates of everything that's going on. And if you get an alarm, it looks just like a rideshare app. You get, this is what's going on with your machine, accept the job, and it tells you where you're going. Use Google Maps or Apple, and you're off and running.
Off you go.
You know,
And so, yeah, the importance of taking those job site photos is that they are GPS located because they're cellular based, right? But you don't know if it's the front side of the cabinet, the back side of the cabinet, is it actually mounted on the wall beside it? So having those pictures, because it's not the same technician that's going to always show up to the same job. But again, taking those two things into consideration that we all are short of, which is time and money, right? We want it to be as seamless as possible, that when they get the job and they pull up the photos, like, okay, well, it's on that system and it's on that side. So there's no searching around pulling off panels that don't need to be removed. And as Kyle pointed out, it's just simple as following the directions in Google Maps or Apple Maps to get there.
Wow. Kind of actually, both of these came from Andrew, so this is kind of timely. So one of the things that Andrew had mentioned, he was asking if it was primarily based for residential. I mean, this really comes back from commercial compressor monitoring. And
Correct.
like the HVAC has kind of evolved as an additional opportunity to use the technology. Now, in the scenario, like say we are on a grocery or a refrigeration rack installation with multiple compressors, can we still monitor that system with a unit for each compressor?
Yeah, so SAMMi is designed to be per compressor. And the reason that that's done is we've all had the issues of the lead and the lag compressor, right? And which one's causing the issues. We've got a system-wide issue, and we're trying to determine which compressor is causing the problems, or which compressor the system is causing a problem for. By monitoring each one, we can really diagnose more properly where the problem is system-wide. Eventually, without SAMMi, you're going to walk up on a dead compressor. But SAMMi's job is to protect that from happening and point you in the right direction towards the right compressor. We have lots of issues with tandem compressors when it comes to scrolls. And everyone that replaces a tandem scroll compressor knows exactly what happens. You don't replace one compressor, you replace two. And if we can prevent that from happening, that would be great. So, and again, all of those things were built in with our, stealing your phrase again, tribal knowledge from the compressor remanufacturing. And all we know is compressor failures. And so by all means, if we can prevent them from happening, we want to. And whether it's from the residential side or to the commercial and industrial side, again, SAMMi doesn't care what he's hooked up to. He'll do the work. He'll take any job.
Now, on the installation, do you recommend using like T-access fittings on the service valves, or are you direct connecting those with?
Yeah, so we're using the same service ports that the technician would already use. So just with a Schrader valve connection, and we go directly on, and all of our instrumentation is rated for commercial work. So there's not a fear of, do I have a residential model or do I have a commercial and industrial model? It's all rated for commercial grade work. And so the pressures that it can handle, as Kyle pointed out before, the amperage that we can handle or voltage that we can handle is commercial as well. But it can do the residential work without any issue at all.
All right. I'm glad you brought this up, because I'm sitting here in the back of my mind thinking, okay, what else can we do with this? Because we are measuring superheat, subcooling, ambient temperatures. We're measuring compressor amp draw. We have a unit model. I could see the possibility of calculating SEER capacities. Another one that came in, could it be used for LEED certified? Remember, if we're putting this on a new installation, we have baseline measurements of the performance of that unit. So we're monitoring its entire life. I sit in on a committee that it's going to happen. Our utilities are trying to look at different technologies that would allow for connected commissioning, a way to validate the performance of a system when it is installed. And so manufacturers are looking at, well, what data do we need to feed? Well, it's all this. This is what you feed it. But that's what it comes down to. Are we performing? What does my curve look like here? And I'm going to monitor it over time. And even with an inverter scenario, right? If my refrigerant pressures are staying the same and my compressor amp draw is going up because it's trying to maintain capacity because it's been losing refrigerant or whatever, that's things that can be tracked. So the possibilities are just endless.
Correct. And the data that SAMMi is collecting is the user's data.
Yeah.
We, of course, are reviewing it and running it through our system to help find those issues. But once all the data is logged, the data is theirs. They can download the data. They can keep the data. We've built, and Kyle, I don't want to misspeak. But we've built systems that can take large amounts of data and store them and sort them. And Kyle, if you'd want to speak to that.
Yeah, so every bit of data that SAMMi gets is Amazon Web Service hosted. So it's all cloud-based data. So from a security standpoint, that's very important to us, especially as you have every customer has their own partitioned environment for their own sets of security. All of that data resides in their partitioned portion of the cloud and is their data that they own. So at any time they can pull that down. We have really easy tools to pull down 24 hours and 30 days worth of data. You don't realize how much data 5-minute pulls of compressor information is over the course of a month. That gets to be a pretty large amount of data,
a lot of files,
relatively quickly, but it's there. And we're constantly looking for new things to train the AI portion of it on, of things to look for and things to calculate. So where we find tremendous benefit in the technician feedback is, if we would like to calculate something and all of that data is available to do it, AI is really good at those types of tasks.
Yeah.
And so we feed this data through and we tell it, now we want to calculate this instead of, or in addition to. And so it continues to get smarter and smarter and smarter. I would love over time, and our vision is that we continue to feed failure patterns back into it for pattern recognition.
You bet.
And that's really where we want to go. But, especially in the HVAC industry, with all of the systems being different, that's going to be a gradual thing. And so, technicians that have the same setup 20, 30 times across grocery store chains or things like that. Those will be able to train very quickly. Very specific systems, that's going to take time. And we can load manufacturer curves in and look for variances there. But it's such a fascinating industry and such a rich industry, and that everything is a bit custom, even when it's supposed to be the same.
That's right.
And so continuing to put those things in and those nuances, this isn't a situation that the AI portion of SAMMi is never going to replace a good technician. What it is able to do is leverage those really good technicians to help bring the boats up of everybody.
Yeah, absolutely. It broadens that curve. Carl, you are thinking exactly like I am. This is a personal plea to the educators that are on here. I mean, I think I would probably take on this task myself, but there's educators out here that have classrooms full of equipment that could absolutely budget for putting SAMMis on your equipment and working with your students to see some of these. What happens when a capacitor fails? Because it's showing how things react when problems occur. And that's invaluable data for everyone.
For sure.
Wow.
For sure. And again, as Kyle pointed out earlier in our conversation, that is, yes, the data and the solution sets are training SAMMi because that's the way machine learning works, but it's also training the technician.
Yeah.
And just the same as you walk onto a job site, like, I've seen this before. SAMMi is saying the same thing in its own language. And so what we want and what we hope to happen is that even though that notification comes up for the technician on the app, that they've seen that system before, they've seen those errors before, and now they also know, I know what's going on here. SAMMi's led me down this road already. And so now they're learning as well, because there are millions of systems out there, and we would love to have a SAMMi on every single one, but that's not necessarily the case. So there's an opportunity for SAMMi to have led you down a certain path and help you fix an issue on a system that SAMMi was monitoring, but your next job is not going to have a SAMMi, and you're going to have the same sets of data, just not recorded by SAMMi. But at least now you have that tribal knowledge now built in that says, I've seen this before, SAMMi helped me through it. Now I can apply that knowledge to the next system that SAMMi's not on.
Man.
But we would love for SAMMi to be on that next job. Just
to
be totally clear.
Yeah.
And I would be remiss if I don't mention, because we think it's very important, is one of the amazing things AI was able to help us do early on is SAMMi can translate itself into essentially any language that it needs to be translated into. So it's loaded with English and Spanish right now. It is just as easily as us pushing the language model through, and it's designed so that it is not so word heavy, that literally any language it can be translated into for the user, so that both the app and the web-based is showing a user information in their native language. That way we're not having to mentally translate and technically translate all at the same time. We think that's critical to setting our technicians up for success.
Man, like, you have built something truly from technicians' hearts. I mean, I'm very excited about this. Another question that came in, and we covered this earlier. I highly recommend you going back and taking a look at some of the presentation we did earlier. Yeah, you can do custom parameters for your inputs and the alarms. And something that I wanted to ask about, I had noticed on the slide too, that you could even, like, say if we had temperature thermistors and we wanted to do a custom alarm, we could actually use additional units and set up additional custom alarms off from that for the same piece of equipment?
For sure. So if we wanted to add another SAMMi because you wanted to measure ambient across the system, and not only on this side of the cooler or freezer, but you also wanted to measure on this side of the cooler and freezer, and take the delta or the spread across the two. Absolutely. And if the delta gets too large I'll use the example of a walk-in freezer. If this door's been left open too long because they're loading the freezer, and you want an alarm to say that the delta between the back of the freezer and the front of the freezer is too great, normally that means the door is left open.
Yeah.
So you can set an alarm that says, hey, close the door in between trucks.
Yeah.
You know, we don't want to leave this thing open. You're killing this equipment.
Yeah,
but-
first layer dispatch is a phone call to the store. I mean,
right.
It's massive.
Yeah, because what we don't want, you know, is, and what we're trying to avoid is we don't want the first sign of an issue to be your first ice cream customer of the day that says, hey, by the way, all your ice cream's melted. Like, that's not what we want. That's not good for anyone. It's not good for the mom who's trying to buy ice cream for their kid. And it's not good for the store owner. It's not good for the mechanical contractor. It's not good for anyone. So, you know, we really did take an approach of how can we, you know, help everyone throughout the chain of ownership of this problem, so that we can catch these things before you've got a crying kid in the back seat because there was no ice cream that day.
Man.
Yeah. That's
There's
you can tell I've
so
got
many
kids.
solutions. Yeah, I mean that's real experience. Well, I'm sitting here thinking about from like a refrigeration technician perspective. You know, if I've got a compressor rack that's not on a building management system, yes, I can go ahead and monitor my compressors, but I can use a separate SAMMi, and I've got a discharge pressure, and I've got 2 temperatures across a oil filter or a temp right filter or suction filter. Like, there's so many things that I could be monitoring independently while it's monitoring the performance and the operation of my system.
Correct. And Kyle, I think this would be a good place to explain how smart SAMMi is about tying all those systems together so that it's seen as one complete unit or system, not 5 different SAMMis.
Yeah, so it's able both natively. We can go in and we can tie, as Justin said, information between multiple SAMMis together to get custom alarms that this SAMMi is seeing something that is different from this one. This indicates a combination of failures.
Right.
So we can take that higher order. And then for our more sophisticated customers, you know, SAMMi is also capable of, if they want to see things in a different way, we have an API that, you know, users can pull in all of the SAMMis that they have if they have some other custom way that they want to see all of those things together on their own sets of visuals. We know that certain customers have different levels of sophistication. They are really married to what their systems look like. And so we want SAMMi to play as nice with others as it possibly can. And that's the great thing about direct measurement to the system, is it's not competing with anything else. It is getting data purely on a thermodynamic standpoint. It's not getting it from anything else. There's no security with a certain manufacturer or certain control system. Pressures, temperatures, and amperages are, you know, those are free information for SAMMi to go grab and send back in whatever level of complexity you want.
Yeah, definitely nothing lost in translation. But additionally, to go back to that example of setting up multiple SAMMis to measure different mechanical things, it is robust enough to where, and customizable enough to where there's no question of, okay, well, which SAMMi is that? You can name them whatever you want. You can name it, this is the oil separator, or this is the evap coil, or this is the compressor. So you can really assign those things and, you know, really list them in a subset of, here's this system, and here's all the SAMMis, and here's all the things that the SAMMi is measuring, so that when an alarm does go off and a call is dispatched, it knows that, hey, there's an issue at the coil, not at the condenser. So again, pointing them in the right position at the right time with the right information is key.
And I know we've got a video going right now. We've hit on it a couple of times, and you can go to the YouTube site to see them. But you know, the programming of alarms is not, you don't need a master's degree in rocket science to input an alarm. It is very simple, pluses and minuses, very simple sets of logic. Select what your input is and what you care about, and you can get as complex with those as you want. And you can delete them if you don't like the output that you're getting. So we set it up so that it is infinitely complex if you want it to be, but it is so simple to implement, and nothing is broken. It's not tripping the system. It's not doing anything. You just might get a couple of notifications that something has gone awry. And so you get feedback that your alarms aren't working exactly how you want, but you can look at the system and see that from a physical standpoint, everything is still just fine.
Yep. And again, the programming side of it was looked at again from that the loss of tribal knowledge, that we're not expecting the technician that's receiving those calls to go in and set all these alarms. This can be your most highly coveted employee that does have all that tribal knowledge to set up these systems and to help. And then again, we're going to be training the user, right? We're training that technician, because now they're going to see the rules that were set up. And if the guy that's been on his tools for 30 years think that that's important, and those are when he or she would like to see alarms.
Yeah.
The younger technicians are going to start noticing that too. Like, oh, I didn't realize that I need to pay so much attention to name that issue. So
exactly.
And eventually, again, they can take that knowledge moving forward and start setting up their own alarms. Or if that field is too wide or too narrow, they can go in and adjust those things. So if you do start getting the dreaded nuisance alarm of pressure delta being too tight, well, we can go in with a few clicks from the admin side and widen that range. The nuisances will stop. So it is meant to be fine-tuned by the user.
You know, there were a couple questions that actually relate to the job assignment that is on here. Is there a maximum number of units that can be in like a proximity, like a building, or a maximum number of units that can be connected to a contractor's database, to their dashboard?
No, SAMMi, you can put as many SAMMis as you want. And that's really where the pictures and the naming of the devices gets really important, because everybody, when you're setting 6 of these up, you think, I'll never forget what that is. But at 2 a.m, when somebody else responds, they certainly forget what that is. So no, you can set up as many as you want. The GPS side of it, you know, is helpful in getting you generally where you want to get to. But those photos and those naming conventions are really what help you figure out what you're looking for, and can go find the device. And then each device has its own ID number on the outside of it when you get there.
Right.
So you know which one you're looking for.
And so we've made it that way so that it's scalable. So if you've got a cold storage facility that is several hundreds of thousands of square feet and have dozens and dozens and dozens of refrigeration systems on there, we can monitor the whole plant.
Yeah.
If you've got one ice cream shop with one freezer, we can monitor that. So it's completely scalable.
Man, I could go on for hours on this conversation, guys. This is fantastic. I'm so glad that you're here.
We'll be at AHR. You guys can come by, see us. We can answer as many questions as you have. We're super excited. We're in SL 3122, so we're in the South Hall. But we will definitely be there. Kyle and I will be in the booth. We've got, you can actually come by and meet the real SAMMi. SAMMi will be there.
Sweet.
Yep.
I volunteer for costumes, by the way.
I do want to mention,
fantastic. There we go.
We've got our QR codes up here. One thing I want to be really clear with your users. So whenever a customer decides that they want to purchase a SAMMi and have a SAMMi, they get the device, they set up their environment at that time. But until you have an environment set up, the best way to see SAMMi in action is to go through the YouTube videos. If you go to the website right now and you attempt to log in, if you don't have a SAMMi, there's nothing to see. So I want to make sure nobody goes and logs in and says there's nothing here. Look at the videos. Once you set up an organization, it starts to grow, and then you can see it from the website. And you set up your staff members, and all of staff members being technicians, they all use the iOS and the Android app. So there's a hardware piece, there's the web-based piece for your administrators, and then there are the phone applications for your technicians. So it's a 3-part system that really goes live once you decide that you're going to implement a SAMMi and once you receive one. So go look at the videos and check those things out. But if you go to the login, you're going to be disappointed this afternoon.
Okay. Well, I encourage everyone, make sure to scan those QR codes, connect with CSG, check out SAMMi, and if you're at AHR, swing by, learn a little bit more. And we're grateful that everyone joined us today, and we will see you all again next week on Did You Know? The ESCO HVAC Show. Good evening, everybody.
Thank you.
Thanks.